Okay, first of all, so sulfur dioxide, the molecular geometry, so looks like a linear, but hey, watch out, there's a lone pair right there. So it looks something like that. So we call this a bent. All right. The electronic geometry, so there are 3 electron groups, right? Electron groups around sulfur. So that's a trigonal planar. So we have one point up, point to the left, point to the right. The best structure of 3 groups is trigonal planar. That's the electronic geometry. All right, now molecular geometry of OF2. If you look at just the atoms, so it should be something like that. See that? All right, so we call this a bent. Yeah, ignore the lone pair, ignore the electrons. Now the electronic geometry, considering the electrons arrangement around oxygen, right? So that's a tetrahedral. So because they are 4 groups, 1, 2, 3, and 4. They are 4 groups that are tetrahedral. All right, next one, phosgene, so pH3, all right? The molecular geometry, look at just the hydrogen, right? With the hydrogen, well, it's tempting to say this guy is a trigonal planar, but hey, hold on, there's a lone pair. You have to consider the effect of lone pair, right? The lone pair will push everything else down, so you're gonna get trigonal pyramidal. But now, electronic geometry, look at the electron group. So we have 1, 2, 3, and 4, the lone pair as well. 4 groups, so the best structure is tetrahedral. All right. Last one, silicon bromide, right? Silicon tetrabromide. This one, so you have to draw normally you have to draw the Lewis structure on your own. Yeah, for this right now we just practice, so some of them might just give you the Lewis structure, but on the quiz, on the exam, you have to come up with your own structure, right? So silicon tetrabromide looks like this. So the molecular geometry, totally tetrahedral, all right? And the electronic geometry, well, how many electron groups are there? 1, 2, 3, and 4, so also a tetrahedral. All right. All right, last one. So identify the molecular geometry and the electronic geometry for each of the following. All right, so we have carbon and oxygen here. All right, start with 1. 1 for non-central, no lone pair, trigonal planar. All right. Electronic geometry, so 1 electron group, 2, 3 electron groups, so that also trigonal planar. Carbon number 2, so molecular geometry, no lone pair, 1, 2, 3 groups, so 3 atoms around this carbon, also trigonal planar. Electronic geometry, so look at the electrons group 1, 2, and 3, also trigonal planar. Here we go. Next one, so carbon right here, molecular geometry 1, 2, and 3, same thing, no lone pair, trigonal planar. Electronic geometry, same thing, 1, 2, and 3. So I'm talking about bond. They are this bond, 3 bonds total. So trigonal planar, same thing. All right. 4, so oxygen right here. Also watch out. So oxygen, the molecular geometry, look at the number of non-central. So we have carbon, right? 2 lone pair, push everything down. So this is not linear. Push everything down, you're gonna get bent. Electronic geometry. So how many electron groups are there? 1 group, 2, 3, and 4, 2 bonds, right? So that's a tetrahedral. Last one, last carbon, so 4 bonds, right? So 4 non-central, no lone pair, tetrahedral. Electronic geometry, so how many electron groups? 1 group, 2 group, 3, 4, also a tetrahedral. Okay. All right. One more time. So this one is about polar or non-polar molecules, but you have to, if you still remember, like when you consider a polarity of the molecule, you have to, 1, look at the, is there a polar bond? And 2, look at the geometry, if all the dipole moment cancel out. All right. So I'll show you the first one. So sulfur dioxide, if you draw the Lewis structure, you should get something look a bend like that. Right. Now, considering 1 bond at a time, so sulfur chlorine bond on the right, of course, chlorine beats sulfur, point toward chlorine. Chlorine and sulfur to the left, point toward chlorine. So the net dipole moment point down, on the chlorine side. Okay, so this is a polar molecule. HCN, let's see what's going on. So the Lewis structure is going to be something like that. All right, so it's linear. The bond on the right, so carbon and nitrogen. So nitrogen beats carbon for sure, higher in electronegativity. So point toward nitrogen. Carbon and hydrogen. If you still remember, carbon and hydrogen bond is a non-polar bond, so you can just ignore it, right? So the dipole moment of this molecule going toward nitrogen, so it's polar molecule. All right, next one, carbon disulfide. All right, so the Lewis structure should look like that, and this is linear. Carbon, sulfur, of course, sulfur beat carbon, right? So go towards sulfur. Sulfur on the left side, go towards sulfur as well. What's going on here? They cancel in the middle. So CS2 is nonpolar compound. Now, CH2F2 is totally a tetrahedral. Okay, but if you look at the CH bond, you can ignore it. They are nonpolar bond. But CF bond totally go toward fluorine. Then the net dipole moment go that direction on the fluorines, the side of the fluorine. Now, next one, polar molecules. Next one, we have silicon tetrafluoride. So this is totally tetrahedral as well, right? And the dipole moment, each bond, so silicon fluorine bond right here, go toward fluorine. Silicon fluorine bond right here, go toward fluorine. In a tetrahedral structure, if all the dipole moment cancel in the middle, so the net dipole moment is 0, basically, so nonpolar. Last one, we have pH 5. So this is this trigonal bipyramidal structure. Okay, let's see what's going on. pH bond, so phosphorus beat hydrogen, of course. All of them going to point toward fluorine. Phosphorus. All right. The dipole moment of 3 bond right here. This is on the same plane. This looks like a trigonal plane now. See that? So they cancel in the middle, and the top pointing down, bottom pointing up. So they also cancel in the middle. So the whole molecule is nonpolar. Okay. So take some time to be familiar with this. So first off, you have to be able to draw Lewis structure and predict the molecular geometry, and then consider the polar or nonpolar bond. Okay. All right. So practice that right here. So class activity number 5. And this is the last video of this chapter. So I'll see you again on chapter 10. We're getting there.